Good morning, everybody. Today I will be talking about Melanie Perkins. She is the one she's the one who made Canva, and she made designing easy for everyone. So let's talk a little bit about her background. She was from Perth in Australia. She started her first business in high school, where she started teaching her peers to learn design programs. But her major breakthrough was in college, when she started a yearbook designing tool. She noticed all her friends struggling with the complex design programs, and she used that frustration and created Fusion Books, which one of the main features was its drag and drop interface. And using that feature, it was easy for them to design yearbooks. So she started. So Fusion Books is what led to Canva, and she pitched her idea to over 100 investors, but she faced rejection over and over again until she finally launched the app in 2013.
What's it called?
So Canva's main revolutionary feature is its drag and drop interface. Usually design software requires a really steep learning curve, but this feature ensures that it takes away from that curve. You don't need a technical background or any creative skill to be able to use Canva. It made designing accessible to the crowd. So Canva's design system is what sets it apart. Imagine your design system to be a bit like the Lego set that your kids use. Over there, you don't need to build the bricks from scratch. You have the bricks and everything just snaps together, and at the end of the day, you have a really, really beautiful piece. The Canva's design system is like that. It ensures that you don't have to build your own template. You can build off of the existing templates, and using that you can personalize it and make it your own. Another one of Canva's features is its smart grid and snapping. It ensures that if you change an element, it just automatically adjusts. Everything else changes. So you don't need to know the visual hierarchy or any technically. Canva's grids will do it for you. Canva has a feature that I think is really interesting. You can collaborate with multiple people at the same time. Multiple people can design together. They can leave comments. They can leave feedback. They can give suggestions. Everything is saved in the cloud, and it has updates in real time using WebSockets and Firebase. WebSockets is basically a client-server connection, and Firebase is like a database where any changes that you make are saved immediately, and they reflect across all the platforms immediately. And Canva's in the cloud. So imagine you have a cupboard and you have all your belongings in there. Now, in case of an accident like a fire or a flood, all your belongings will get spoiled, right? Now imagine within that cupboard you have a locker, and everything that's in the locker is safe and it won't be damaged. Now imagine you had a key that you could open the locker from anywhere. So your cloud is like that locker. Anything that you save in the cloud will remain there, and you can access it from anywhere at any time. So I can take it from my mom's phone or my laptop. I can access it from Australia, or I can access it right here, right now. You can use any devices. It's always safe and it's always accessible. Melanie Perkins has a really inspiring story. She faced rejection so many times, but she still persevered. And today she is one of the most successful female entrepreneurs right now. She made design accessible to everybody. She saw a problem, she fixed it. She proved that you do not need to have a technical background to be able to make a change. Any questions? Thank you.
So hello everyone, it's a pleasure having you all today. Today I'm going to talk about a famous personality, Dennis Ritchie, a person who changed the whole world. In the late 1960s, computer was still in its childhood. If you wanted to talk to the computer, you had to talk in binary, which was 101101. So now you, ma'am, 101101. Could you understand anything? No, right? So this was the language. If you wanted to talk to the computer, this was the language you had to speak. So now let's imagine a country named Robotland. So if you wanted to talk to the computer, you had to speak in binary, like just as I said. So now, what is an operating system? An operating system is a system which controls the computer, or is like a computer manager, which manages all your data. The Unix operating system. The Unix operating system is an operating system which is calm. It is non-fashionable. It is secure and easy to use. It is not too complex and easy. Syntax that shaped generations. This is when Dennis Ritchie stepped in. Dennis Ritchie was influenced by the language called B and created the language called C. He created the language more easy, and he didn't just create it so that the innovators could only write the code. He created so that the innovators could easily also understand the code. Write once, run anywhere. As you can see, a code. This was the code which was easy to explain or to understand. So this was a code which Dennis Ritchie made so that the people could understand and also type the code. Dennis Ritchie made it less time consuming and less cost, so that the people and less maintenance, so that it was easy to use the computer. And he also thought that he could make it more not too complex and easy. So Dennis Ritchie co-created the Unix operating system. He made the Unix operating system not too complex, very easy to understand. So before creating the Unix operating system, Dennis Ritchie was influenced by the operating system called Multics, which was rejected because it was too complex and too heavy. So that's why the project was rejected. And Dennis Ritchie thought that there were some good points, like it was secure, it was easy to use, but it was too complex. It was compact, and some of the hardware devices were small and easy. So Dennis Ritchie thought that he could make the Unix operating system more better and more easy and more complex, and he made it more easy to understand. After Dennis Ritchie made the C programming language and co-created the Unix operating system, he won one of the two major awards. The first award was the Turing Award, which was also called a Nobel Prize Award. It was given to the people who made computer history. So he got this award when he created the when he created the C programming language in 1989. The second award was the award which was called the Medal of Technology Award, which he won with Ken Thomas for co-creating the Unix operating system. Any questions?
Yeah, I have a question.
Yes, sir.
About the binary.
Yes.
Okay. So, do you know what is compiler and assembler? And if you know, what is the difference between compiler and assembler?
So compiler, I think, probably makes it easy for the user, or compiles the text. And what was the other thing? Sure. Thank you.
Yeah.
Whose work you have come across hundreds of times in a day, but whose name you may not know. Her name is Margaret Gould Stewart, and she has shaped how billions of people interact with technology. In her background, she didn't start off as a techie or a coder. She started off directing music videos, telling stories through rhythm and visuals. But soon she discovered her true passion, product design. And what is product design? Product design is the art and science of creating simple products which feel accessible and intuitive. In other words, good design solves real problems for real people in real time. Take the Facebook like button, for example. It's small, sleek, and almost hidden. But every time you press it, it gives a hit of dopamine. And without realizing it, you're giving instant feedback. That's just some of her work. Let's look at some other. At YouTube, she worked on uploading videos, turning a complex process into something anyone can do with just a simple click. At Facebook, she worked on the like button, something tapped on billions of times in a day. At Google, she worked on Chrome and search, making it more inclusive, trustworthy, and trustworthy. Her philosophy is simple: every pixel matters. She tests relentlessly, prototypes quickly, and above all, designs for everyone. That means every culture, language, and ability. Which proves that design isn't just for the majority, it's for every user. Why she inspires me is because she doesn't think of design as a decoration. She thinks of it as a strategy. She designs with real people in mind. She always asks, are we respecting people's time, emotion, and attention? So to sum it up, Margaret Gould Stewart shows us that behind every click, scroll, or even a web page is a person who has spent hours trying to perfect your design. Any questions?
You said that she didn't start as a technician.
Yeah.
Yeah, so she started as a different profession. And then she basically found out that she should do more.
Yeah.
Whatever. So I want to ask you, what is your hobby?
My hobby is to just build projects which have a very simple UI, so that any person just knows what to do. For example, in Google, the search button, you exactly know what you want to find, and it also gives recommendations. So even if you just type a single letter, it gives all of the recommendations for that. Thank you.
Hello everyone, I'm Adabhya and today I will be giving a presentation on Margaret Hamilton. In the 1960s, when most people thought that computers was some kind of magic and women belonged far from them, one woman walked into MIT's instrumentation lab. Her name was Margaret Hamilton. In the 1960s, MIT played a critical role in the development of flight software for NASA's Apollo program, which landed humans on the moon for the first time. Margaret Hamilton was a key contributor to this. So Margaret Hamilton grew up with a passion for mathematics and philosophy, and soon she joined MIT as a programmer. And initially she hadn't even shown any particular interest in programming or software engineering, but she took up the job to provide for her family while her husband was studying for law. Soon she became a self-taught programmer, which was very rare, especially then. When Margaret Hamilton was working with computers and doing software engineering, the term software engineering didn't even exist. She was the one who came up with it. At first, a lot of people used to kid her for such ideas, but eventually one of the most respected hardware gurus said to everyone in the meeting that he agreed with her that software engineering should also be a discipline just like hardware. So about the main code that got humans to the moon, it had real-time and interrupt-driven operating system, which meant that real-time meant that the code could not even pause or stop for a second. It's like in the reflex game, where even if you stop for a minute, something will go horribly wrong. And it was interrupt driven, which meant that if a more important task interrupted the one it was doing, then it would pause this one, do that, and then go back to this. It had error recovery, which meant instead of crashing when it got overloaded, it could revive itself. And it was developed on punch cards. So back then we didn't write lines of code. Instead, people used to punch in these cards around the size of $1. And if you made a mistake in punching them, then your code could go wrong. So you had to make sure that they were in the correct sequence in the stack, and they were punched very precisely. When Margaret Hamilton's daughter, Lauren, was playing in MIT's instrumentation lab one day, she accidentally launched one of the programs that was intended for use before the launch of Apollo program. She accidentally launched that program, and Margaret Hamilton quickly realized that things would go wrong if one of the astronauts accidentally did this. So she gave her code better error recovery, and on the day of Apollo 11, the code it started giving out errors, but because of her error recovery, it managed to stay calm. So she was later in 2016 awarded the Presidential Medal of Freedom, which is the highest civilian honor that the US can bestow. Finally, I would like to end with a line from Margaret Hamilton. Never let fear get in the way, and don't be afraid to say, I don't know or I don't understand, because no question is a dumb question. Thank you.
Good morning everyone, I'm Rajvi Rajguru and I'm going to be talking about Linus Torvalds for my hackathon project. So I chose him because he inspires me the most, showing how a single man's curiosity and determination can change the world of technology. So in Finland, 1969, there was a boy named Linus Bentek Torvalds, and he wasn't loud or sporty. He was rather quiet and curious and kept to himself. And his journey in computing began thanks to his grandfather, who gifted him an old Commodore VIC-20, which is just an old computer. While most kids around his age used it to play video games and just tool around, he wanted to know how those games were made and what did the computer know what to do. So he started off with writing tiny programs and seeing how the machine responded. And then later on, this passion turned into his career. So now you'll be wondering what a kernel is. So think of your computer as an hotel, and the manager is a kernel. So a manager manages the hotel, and without the manager, the hotel will fall into chaos. So the manager has to manage so that it wouldn't fall apart. So same over here, kernel is there because if kernel didn't exist, then there would be no way for the software to communicate with the hardware. As you can see over here, the software between the software and the hardware, there's kernel, and so it's made for better communication between them. And over here, there are features of a kernel. So it manages your user, network, file, process, driver, management, and it is at the same time it's secure and it's portable. So Linus got the name Linux by combining his own name with Unix, which is an operating system, and he got the name Linux. While most of the companies made their code and just kept it away, locking it from the public, he made it open source and posted on internet saying that I need some help with my operating system, nothing big and professional like a GNU. So people around the world started helping him for his operating system, adding features, fixing bugs, and etc. And this was revolutionary because, as I said, the rest of the companies locked it away, and he made it open source within a global collaboration. And did you know more than 96% of servers have been running on Linux kernel, which is the backbone of our internet today. Given enough eyeballs, all bugs are shattered. This is a quote from Linus himself, indicating that if I made a code and then Pooja ma'am went through the code and checked if there are any bugs, and she does find it, then she will be able to fix it, which is the meaning of this code. It's about teamwork and teamwork. Nowadays, the world runs on Linux. As I said, 96% of servers have been running on Linux, as well as Android devices, which makes 3 billion smartphones run on Linux. and it has also been used in top 500 supercomputers. It has been used in the ISS, NASA rovers, and the SpaceX rockets. It is also in embedded systems like cars, refrigerators, washing machines, and toasters. Other contributions. So, not just his creation was not only just an kernel, it was Git and Rust. So, Git is like example. Take an example. You're writing a book with 100 people. A lot of chapters would be there. They would get lost, and the book wouldn't be quite nice. So, the Git tracks what a user is doing, what changes did he add, and when did he do it. And Rust is just an programming language he created, which was because more than 30 years the Linux was running on C languages. So he decided to create his own, which was way more safer, added and had way more features, and fixed bugs. Thank you.
Good morning everyone, I am Eklavya Chaudhary and I will be talking about microservices architecture, and my personality is Werner Vogels. So, who was Werner Vogels? He worked as a radiologist doctor at 21 in Amsterdam, but due to his emotional toll and the pressure he was facing with critically ill patients, he decided to quit his job and pursue computer science further. His early life. He completed his PhD of computer science in Amsterdam. Then he moved on to INESC Lisbon, where he was a senior researcher and built fault-tolerant distributed systems. Then he went to the Cornell University, where he was a research scientist and researched about many facts and built new theories. Then he founded the RNS, the Reliable Network Solutions, with his co-founders Robert and Kenneth. These all experiences helped him lay the foundation for AWS. His architectural philosophies and principles. First, everything fails all the time. This encouraged developers to think that any app would fail at any time, so that developers should be ready for when it happens. Then, simplify complexity. This meant that apps had huge numbers of complex problems, but the trick was to hide it with a simple interface. Then the last one, you build it, you run it. It encouraged developers to take responsibility of what they had built and to run it with managing it. 3 services that changed everything. First one, Simple Queue Service (SQS). This worked like a chat box for apps, so without being connected together, they could interact with each other easily and flexibly. Second, Simple Storage Service (S3). This was a major change as it protected data without the risk of data leaks and without having to worry about hard disks or backup files. Then the last one, Elastic Compute Cloud (EC2). This changed completely how companies managed computing services, as it gave companies an opportunity to use servers from AWS instead of having to work with big machines. Monolithic versus microservices architecture. Imagine monolithic architecture like a big Lego block where all of the services are connected together, and if one of the services gets damaged, the whole block has to be disturbed to repair it. But whereas in a microservices architecture, it is all loosely coupled. That means that each of the services is independently connected, so that if one of them stops working, the other one takes over and it runs smoothly. How AWS supports monolithic and microservices architecture. First, with Lambda, data can be used serverless so that it is more efficient. Then with container management with ECS, it means that data can be stored on servers using ECS with containers. Then streamlining development. Streamlining development tools help developers to efficiently develop code without having to hassle with multiple problems. Now I'll be talking about the real world systems where AWS is used. First, Spotify. It uses Spotify. AWS is used by Spotify to create recommendations and track what the user is listening, or see what the user likes the most. Then we have Uber, Airbnbs, which track your traveling log and suggest where you should travel next. Thank you.
My name is Nidesh Wadhwani and I'll be speaking on the tech personality Tobias Lutke. So Tobias Lutke was born in Koblenz in Germany in 1980. His parents gifted him a Schneider CPC computer at the age of 6. At first he used to play games on it, and later he thought that what would happen if I would have rewrite the code for the games. So by the age of 11 he started rewriting code for games, and he was even playing around with hardware. And school wasn't his favorite, so he left after the 10th grade to continue with his programming. He moved to Canada without a job, turning his hobby into his job. He created Snow Devil, which is an online snowboard shop using Ruby on Rails, which is a programming language used to create websites. In 2006, Shopify was born. Shopify is a SaaS platform, software as a service. So this means that you can use it online without actually installing anything. So it's just like a magical backpack which contains all the tools we need wherever there's internet. And Shopify's architecture is modular and multi-tenant. So it's like a mall where each shop is separate, but everyone shares the same strong electricity, plumbing and security. So the shop owners don't worry about the updates, servers or any security. Shopify handles all that so that they can focus on their sales. Shopify's headless commerce separates a store's look from its engine. This means that brands can make their stores look however they want without touching the system that handles the payments, orders and inventory. So the Hydrogen framework is just like a set of Lego blocks which has pre-built functions and use React, which is a web tool to make fast and beautiful websites. Shopify is just like a superhero team for businesses. It covers easy store design with drag and drop tools, global selling on websites, social media and even in person, secure payments and fraud protection, shipping tools to track the orders worldwide, and a massive app store to add custom powers like giving discounts or sending marketing emails. Whether we sell 5 items or 5 million, Shopify always grows with us and helps us track our success by providing analytics. Shopify never stops upgrading. In 2025 summer, it added 150 plus updates ranging from AI-powered product suggestions to faster personalized checkouts. It even leads the way in social commerce by connecting with TikTok, Instagram and other social apps so that the customers can shop without leaving the apps. Tobias always wants that his progress should make the world better. He, together with his wife, started the Thistledown Foundation, which donates millions of dollars to children's schools, hospitals and even in projects to fight climate changes. From coding in a German house to becoming the world's largest e-commerce company CEO, his journey shows us how passion can turn into global impact. He wants everyone who has a big idea to turn it into a business. Shopify's superpowers like SaaS-based headless commerce, app integration, and secure checkouts help anyone anywhere in the world to turn an idea into a business. I would like to end by a famous saying: the future of commerce is not in the hands of few, but in the hands of many. My job is to arm the rebels. Thank you.
Chai was born in Chennai in India. He was a very curious boy. He would remember every single digital number he would type, and he went to IIT in India and Stanford in USA that headed to Google.
He was a product manager in Google. He was working on toolbars and he was thinking, why don't we make our own engine? Because at that time the technology was very slow. It was feeling outdated. It was not good. It was not feeling very good. So he led the team to make the V8 engine. The V8 engine was fast, free to use, downloadable, and it was very easy to access. Sundar Pichai led the team to make the PWA2 progressive web applications like Flipkart, Twitter, and Trivago. So in PWA is like your app store or Play Store. Just think it like your Play Store. Contribution to Google. Sundar Pichai contributed Gmail for mailing and Google Maps for a better route. And he even said it is important to follow your dreams and your heart, do something that excites you. Google and artificial intelligence. Sundar Pichai is right now trying to put artificial intelligence in everything, including your Google Lens. So it's AI recognition. And fun fact, did you know that Sundar Pichai's current net worth right now is $1 billion? Thank you.
Everybody is well aware of Google. What do you think how Google is earning?
How
Google is earning money?
So
Everybody is free, right? It's like it is Google is free.
So I think there are some apps that are not free. So there is a limit that you can search on and the other limit that you need to pay for it.
You can get a subscription.
Yeah.
That is one way. There is, apart from this, there is huge money coming from some else. Advertisement to your data. So research will take you for the whole day. And just try one thing. Whenever you are searching something on Google, then notice after 1 day or 2 days, you will get similar kind of problem.
Yeah.
If you are searching for cars, then
It will just show you cars in your playlist. That's AI.
That your search is going to the market, right? Where all the companies are registered, all cars are registered. They get that this person is willing to buy a car. So they will start sending you that your personal mobile is how they are earning one type of money, right? Whenever you open anything, any news reading or any kind of article reading in mobile, you will get lot of advertisement, pop-up, and those are kind of earning. Yeah, also company like TEDx has programmed their own cloud.
Yeah.
Like it's email.
Yeah.
People thinking that for Google Workplace.
Yeah.
Buy license. Then they people like email or cloud space. So on the company.
Yes.
That also reduce. Google has also cloud ECP. Google Cloud platform where go and buy space and also a lot of business models out there.
Anybody has any questions?
Your presentation.
Thank you.
It is colorful and very colorful, right? And you look like, well,